Hello, we are doing chapter 7.2 today, which is solving by subtraction. If you had no issues with solving by addition, then this won't give you any trouble either. I'm going to show you a few examples and make suggestions as far as how to solve them, and to solve them correctly would be a good thing. For instance, if you had this problem, 3x plus y equals 24, and 3x plus 5y equals 36. You've got a pair of simultaneous equations, also referred to as a system of equations. And you can see that, just like last lesson, you do have variables that have matching coefficients. So you have 3x and 3x. In lesson 1, you would have had a 3x and a negative 3x. So you can see that when you add them together, you're able to eliminate the x's, find out what the y is, and go from there. But it's not quite so easy this time, because now our 3x's are identical. One is positive and the other is positive. So, as you might have guessed from the title of the lesson, you're actually going to be subtracting. Okay, and what we're going to do, I'm going to adjust my camera here, is we're going to subtract. Now you can mentally subtract. I'm not very good at that. So I'm just going to go ahead and I'm going to add the opposite. So I'm going to go ahead and make every sign opposite of what it originally was, and then I'm just going to add basically my columns, okay? So 3x and a negative 3x is 0, which was my point. A y and a negative 5y is negative 4y, and 24 and negative 36 is, I think, negative 12. Okay, so I get 4y equals negative 12. And you can see, of course, that y would then equal 3. So when we divide negative 4y by negative 4 and negative 12 by negative 4, we would get y equals 3. Now, of course, because these are simultaneous equations, we are looking for the point x and y that would make both equations true. And so we have found the y. Now our goal is to find the x. So we're going to take our value for y equals 3 and we're going to plug it into the top equation. It really doesn't matter which one you choose. Okay? So if I have 3x plus y equals 24, I'm now going to substitute the value I just found for y, which is 3, into that equation. Okay? I'll subtract 3 from both sides. I'll get 3x equals 21, or x equals 7. Okay, so now I have a value of 7, 3 for my ordered pairs. Now, because it's an equation that I'm dealing with, I can know exactly if I'm correct or not. So I'm going to take that 7, 3, and I'm going to plug it into my second original equation, which was 3x plus 5y equals 36. Okay? Whoops, I'm giving you a peek at what comes ahead. All right, so if we have 3x plus 5y equals 36, and I'm going to substitute 7 for x and 3 for y, I can see I have 21 plus 15 equals 36. 21 plus 15 does equal 36, so I know I'm correct. Therefore, I have found my answer, which is 7, 3. So you do have to go through more steps. You should be using a lot of paper. And yes, I am invested in the paper company, in case you're wondering. Let me show you another problem. If you have 6x minus 4y equals 42 and x minus 4y equals 17, again, you have matching coefficients, 4y and 4y. Both happen to be negative, okay? So I'm going to draw my line and change my signs to exactly opposite. Okay, now if you can mentally just think, okay, I'm subtracting, and you're good with that, that's okay. I'm not. I have to remember that every term is being subtracted, and generally what I find is that students forget that they're subtracting partway through. 6x plus negative x is 5x, okay? the y's cancel out, which was my point. Okay, and then 42 minus 17, let's just work that out here. We get 5, we get 25, okay? And we can see, of course, that x is then going to equal 5. Okay, then we're going to take this value, x equals 5, and we're going to plug it in to one of the other values. Okay, so if I have 6, and then instead of that x, I'm going to put a 5, minus 4y equals 42. Okay, it's just the top equation. I could have chosen either one. It doesn't matter. I get 30 minus 4y equals 42. Okay, to get that y by itself, I first subtract 30 from both sides. So I get negative 4y equals 12. Divide by that negative 4, and y equals negative 3. Okay? And then again, because I'm a good little student, I'm going to take my values. Now I have 5 for x, negative 3 for y. I'm going to plug it into this equation here. And I didn't bring enough paper with me, so I'm just going to go ahead and plug it right here. And I'm going to say that x, which is 5, minus 4 times negative 3 equals 17. 5 plus 12 equals 17. It's a true statement. I know then, without a doubt, that 5, negative 3 is the crossing point or the solution set for this system of equations. I hope you did well on your test today, and I hope you do great on your lesson tonight, and I will see you in class.